Welcome to this video. Here I'll be solving this sample or mock AP Precalculus free response question. I found this on crackap.com. This is free response test number 8. It's just a sample question. Okay, so I thought it would be a good idea to do this one because the website does give a worked out solution, but when I tried doing it myself, I did it a totally different way. So you can just see a different approach than what the website offers. And I still get the same answer as they do, clearly. Okay, so let's try these out. This supposedly should take only 15 minutes, but let's see. Find the solution of log base 2x minus log base 2 5 equals 2 plus log base 2 3. Okay, so let me do it on a piece of paper, note paper on the side. So I'm going to rewrite the question. Log base 2x minus log base 2 5 is 2 plus log base 2 3. Okay, so I probably want to combine these two logs by properties of logs. So for example, log a minus log b is log of a over b, so x over 5. And I probably want to make this 2 as a log also. I know that log base 2 of 2 squared, let me write this first. This guy is 2 because log base 2 and the 2 to the some power, those are inverses, so you're left with 2. And you think of it as the log and the exponent cancel. So we get back 2. So why do I want to do this? Well, I can combine these two logs. Okay, so this would be 2 squared is 4, so it'll be log base 2 of 4 times 3. Okay, because log a plus log b is log of a times b. So this is log base 2 of x over 5 is equal to log base 2 of 12. Okay, so clearly the insides of the log have to be the same, or we can exponentiate both sides. 2 to the this equals 2 to the this, and then we're left with x over 5 is equal to 12. So that means x is 60. That's how I would solve this first one. Pretty simple. Okay, find the solutions of ln of y quantity squared minus ln2 times ln y is equal to 2 ln2 squared. Okay, so to solve this, I probably want to move everything to one side. So that's what I'm thinking. Ln y squared minus ln2 ln y minus 2 ln2 squared is equal to 0. So I just move this to the other side. Okay, the clue here is it looks like it could be factorable, but it's not quite what you're used to because of this ln2. It's not like a nice integer number. Okay, so if you're not able to factor it right away, this is what the website did. Actually, they just factored it from here. Remember, there's a technique where we can complete the square. Okay, so we can even make like a little substitution. If we let x is equal to ln y to help us visualize things a little better. So it'll be x squared minus ln2 times x minus 2 ln2 squared is equal to 0. Okay, so I don't know if I said this already, so I already forgot. We can complete the square if we're not comfortable with factoring this. Okay, so how do we complete the square? We need it in standard form where it's like ax squared plus bx plus c is equal to 0, which this is. And the a, so the term in front of the x squared has to be a 1, which it is in this case. So we can complete the square. So what do? We add the b term, which is, in this case, it'll be minus ln2 over 2. So we always divide the b term by 2, and then we square it. Okay, and then since we added it here, we have to add it to the other side also. Trying to squeeze it in. Okay, so I just complete the square here. And when we complete the square, we get a perfect square. So it'll be 1, and it'll be exactly what's inside the parentheses here. It'll be 1x minus ln2 over 2. We square it. is or minus 2 ln 2 squared is equal to, this is what, a fourth ln 2 squared. So we can move this to the other side. It'll be x minus ln 2 over 2 squared is equal to, it'll be 2 plus a fourth, which is 9 fourths ln 2 squared. Now we square root both sides. So we get x minus ln 2 over 2 is equal to plus or minus 3 over 2 ln 2. Okay, so now we say x is, we just move this ln 2 to the other side, so it'll be 3 over 2 ln 2 plus ln 2 over 2, or x is equal to the negative plus ln 2 over 2. Okay, so x would be, what would that be? That would be 3 halves plus another half, that's 4 halves, which is 2 ln 2. And x here would be, that would be minus 3 halves plus half, that's minus 2 over 2, which is minus ln 2. Okay, we did the majority of the work. We are not quite done yet because I solved it in terms of x, but our original equation is in terms of y. Okay, so we got to continue. Let me move on from here. So remember our definition of x is ln y, so let's back substitute. So it'll be ln y is 2 ln 2, and ln y is negative ln 2. Okay. So then now we exponentiate both sides. So it'll be y is e to the 2 ln 2, and y is e to the minus ln 2. And then we just simplify. This would be y is equal to e to the ln of 2 squared. We can use properties of logs to bring this coefficient out in front back in as a power. So this one would be just it'll be 2 squared, which is 4. Whoops, it's getting cut off. Okay, and then this branch over here, we can do similar. It'll be y is e to the ln 2 to the negative 1 power. So y is equal to 2 to the negative 1, or we can say half. Okay, so those are our two solutions. Y is 4 and y is half. This is how we do it. Okay, so we can do it like this, how I did, completing the square. In the website, they factored it, but they still made this kind of substitution to help them out. Okay, so that's how I would approach this one. Part C, find integer values of m and n for which m minus n log base 3 of 2 is 10 log base 9 of 6. Okay, so I probably want, similar to up here, make everything in 1 log. And here there's 2 bases, 2 logs of 2 different bases, so I probably want to choose one. So let's pick log base 3, for example. So I want to write m in terms of log base 3, so we can do similar to what we did before, log base 3 of 3 to the m, okay, minus this n, similar to what we did up here, I can move it back as a power. It'll be log base 3 of 2 to the n is, okay, over here, we can use the change of base. So the 10's a constant, let's leave that alone. Change of base formula would be log base 3, 6 over log base 3, 9. Okay? On this side, we can combine the two logs. Again, using the property we used like in part A, ln A minus ln B is ln of A over B, so, or log. Log base 3 of 3 to the m over 2 to the n is equal to, okay, so log base 3 of 9, okay, let me go step by step. Base 3, 6 over log base 3 of 9 is 3 squared. So this would simplify to 2. Okay, so then we get log base 3 of 3 to the m over 2 to the n is equal to 5 log base 3 of 6. Okay, and then once again, I can move this back as a power. So log base 3, 3 to the m over 2 to the n is log base 3 of 6 to the 5th power. Okay, Now we can set the arguments of the log equal to each other. 3 to the m, and I can even rewrite this as a negative exponent. 2 to the minus n is equal to 6 to the 5th power. 6 we can rewrite as 3 times 2 to the 5th power. 6 is 3 times 2. And then we can distribute that exponent since it's being multiplied. It'll be 3 to the 5th, 2 to the 5th. Okay, so now this is in the exact same form. So that clearly m is equal to 5, n is equal to minus 5. Okay, because 3 to the m equals 3 to the 5th, so m is equal to 5. 2 to the minus n is 2 to the 5th power, so minus n is equal to 5, or n is equal to minus 5. And that's how I solved this. I believe the website did it in a completely different way, but this is how I thought of solving this, just using lots of properties and algebraic tricks. Okay, and then finally, this part D is actually quite easy. The graph of this guy is shown below. Given that the curve passes through the point a comma 0, find the value of a. Okay, so let me get a pencil actually to do this one. Okay. Hopefully this is visible on camera. We're given a comma 0 is a point on this curve. So we can just plug in x as a, y as 0. So 0 is equal to ln of a squared over a. Okay, so we just solve for a. So multiply a on both sides, so 0 is ln of a squared. Okay, so when is ln a equal to 0? Because 0 squared would be 0, or we can even square root both sides. 0 is ln a. So when is this true? It is when a is equal to 1, or we can even exponentiate both sides. E to 0 is e to the ln a, which is equal to a. E to 0 is 1. Okay, so a is equal to 1, as simple as that. Okay, oh, we did do it under 15 minutes, and I went a little slow also. Good, okay, so hopefully this helped. This is a good practice problem, especially for these three up here, just being able to manipulate the logs and all that. And hopefully, if the solution on the website didn't make sense, hopefully this video helps you because I solved it in different ways than the website did. Or maybe if mine didn't help, go look at the website. Maybe their solution is more intuitive for you. Depends on how you like to approach things. This is how I thought through it though. Please like and subscribe if this video has helped you as always. And please look out for the next video where I'll continue solving these mock exam problems on that website. The website once again is crackap.com.